Hi all. Good morning. We're still waiting for the opening remark to join. He has some trouble joining in from Google Singapore. Please wait for another 1 minute. I think he's still having problem. I think we can start first. Maybe when he join, we can allow him to present. Stewart, do you want to start?
All right. So,
Okay.
good morning, everyone. Good morning, everyone, to the first week of the Gen AI Study Jam 2025, an event co-organized by Sunway Tech Club and Artificial Intelligence and Machine Learning Malaysia. My name is Jeanette, and I will be the MC of the day. So today marks week one, running from 10 a.m. to 1 p.m. on Microsoft Teams, focusing on LLM models and prompt engineering. So I'm pleased to introduce our speakers of the day. Next slide. So today,
Sarah is in already, so
all right. Today there'll be two speakers of the day, who is Mr. Saad Hamid and Dr. Kuan, who will be sharing their valuable insights for today. And also, before we officially begin, I would like to highlight the Q&A function, as you can see on the Microsoft Teams tab. So throughout this whole sessions, you can ask any questions about the content or the event itself, which will be answered in the Q&A session later on. So without further ado, please join me in welcoming Saad Hamid, the Regional Lead of Google Developer Ecosystem, who will kick off our session with an opening remark.
Awesome. Thanks for the intro. I hope everyone can hear me. I've been facing a tech challenge where Microsoft Teams did not work on my PC, so I had to join from mobile. But finally it works. So I'm very glad to be here, and thank you, Dr. Poo, for organizing and bringing this community together. So quickly to introduce myself, I've been at Google for almost 5 to 6 years now, and I lead the developer ecosystem across Southeast Asia as well as South Asia frontier. So it's a big kind of a very young, very energetic, and very diverse set of countries that I kind of manage and help manage on a daily basis. And I think what's common in these all countries is that they've been part of the tech revolution when it came to the internet and the mobile. But now everyone is seeing this kind of like commonality where everything is moving towards AI. I think it wouldn't be a surprise, like, every day you wake up and you look at your LinkedIn feed, Insta feed, Google feed, and you would be, when you look at the word AI, how many times it shows up on a daily basis. It's crazy. Like, it's everywhere out there. And like things are changing really, really fast. But I think what's really interesting in this kind of like whole change is that there is an opportunity to build something new, which has maybe not been built before. And I'll give you an example of this. So I was recently listening to an interview by Sundar Pichai, who's the CEO at Google, and he was saying that Google or any other tech company might actually be disrupted by some company or some idea which has not even been created before. So this kind of a very kind of a fast, very fine, very fast and crazy kind of disruption is only happening because the accessibility of AI has opened up so much. And this boot camp here that Dr. Poo has helped kind of organize is kind of going to help you get into the midst of understanding how do you use machine learning to either do research, either build something, either infer data, because there are actually practically a lot of different use cases of how you apply ML, whether you are an educator, whether you are a student, whether you're a professional, whether you are at an enterprise, whether you're an entrepreneur. So there's like just so many use cases, which you can use. But before using the use cases, I think what's really important is to get a foundational level understanding, which is why this again thanks to Dr. Poo, his community, and all the organizers of putting this together. Because what we have seen while working with communities, which is Google developer groups and Google developer experts, is that true learning only happens when you come together and you make friends. Because when you make friends, you share ideas, and when you share ideas, you build something, and when you build something, you change the universe or you change Malaysia, and that's what we all want here. We want you to like really learn new things which you have not thought about before, and apply them practically. And I think even before applying them, like having like a study jam is kind of like the best kind of foundation to actually learn that, and then going on from there to apply that knowledge in different aspects of your life. And yeah, one last thing that I maybe want to kind of mention here, there is a very wide range of Google developer products, open source, as well as, I mean, proprietary, but you have access to this like huge kind of database of amazing tech products that you can use. So you'll be surprised that even though I'm leading the developer ecosystem, but sometimes even I am surprised when I found out about a new tool. Like yesterday, I found out about this new thing called Google AI Edge, which is like a mobile app in which you can actually download models and run them locally on your phone. So there's like so much. There's Gemini, there's Google AI Studio, there's Vertex AI, there's Firebase Studio. I mean, there's so many products out there, and you can eventually, get a foundational level understanding through this bootcamp, this study jam that Dr. Poo and team is running, and then you can go and start exploring these amazing tools and build something amazing. So yeah, I think that's pretty much it. One last note, my personal story, I was a community organizer myself almost 13, 14 years ago. So it is amazing to see that you have such a vibrant community here, and you all are coming together to learn something amazing. So again, thank you so much, Dr. Poo, for inviting me. Thanks for the whole community for allowing me to be a part of this. I'm sorry some tech challenges happened, but I'm glad that even though the Microsoft Teams could not work on a Google laptop, at least it worked on my phone. So that's why I'm here. So very glad to be here. And yes, I'll let you on with the going forward from here, and I'll just stick around for a bit. But thank you so much for giving me the opportunity, and I hope to see some of you in person, hopefully soon. Yes. Over to you, Poo.
Thank you.
All right. Thank you, Saad Hamid, for the opening remark. So now we will be moving on to our main speaker of the week, Dr. Kuan Hoong. Next slide, please. Dr. Kuan Hoong, who is the Data Analytics Section Lead at Roche, as well as the founder of Malaysia R User Group and AI and Machine Learning Malaysia User Group, to begin with an introduction to GenAI Study Jam.
Okay, thanks. Let me share my screen. Hopefully you can see my screen. Okay, so the talk today will be two parts. One is to give you an introduction about this Malaysian GenAI Study Jam. So I think a lot of people have not done Study Jam before. So I just want to go through what is the Study Jam all about, and as a participant, what you need to do to actually complete this Study Jam.
So the slides I already shared in the chat. You can actually follow along. This slide you can actually go back and refer again as you go along for this 5 weeks study jam. Okay, so what is a study jam? Okay, so study jam basically is a learning opportunity where we actually leverage on all the accessible learning resources that we have. So basically, we are going to do our hands-on using Kaggle. There will be some resources like books or free online courses that we are going to leverage on. So every week, you will do some sort of like a hands-on assignment. There will be some sort of tech talks and group discussion. So with Study Jam, this is a very good opportunity for people to come together and to get started with AI. So how does this Study Jam work? Okay, so as a Study Jam basically is a collaborative learning initiative. Okay, so we curate all the resources for you. At the same time, we also create a Discord channel. So I hope that besides learning on our own, as we know, we already have gone through this what we call MOOC, massive online open courses. But as you know, when you do all these online courses on your own, most of the time you have a problem of learning on your own that you do not feel that you are being supported. And most of the time you learn all these online courses, usually by the third week or the fourth week, you most likely fall off because of no support, and you don't have a community that you can actually study together. So with this study jam, we actually make an expansion of the existing study jam out there, which is the Kaggle 5-day Gen AI intensive course. So as the name mentioned, it's a 5 days intensive course. That means you have to sit through the whole 5 days course in a week to actually learn about Gen AI. So I have gone through the course. For people who have no background in Gen AI, it's a bit intensive. So what we have done is we've taken every day and we expanded to one whole week. At the same time, at the end of every week, we actually provide support where we actually provide whether it's an online talk or it's a physical talk where you can actually come to Sunway and then you can actually attend a talk by the speakers who is going to talk about the topic of the week. Okay, so with that, we actually hope that with this study jam, it's not just you doing all the courses by yourself. You also have a come together as a community and then work together as a community and also get to know everyone and then learn the topic together. So basically, the objective is to build a foundation of AI knowledge, promote hands-on learning, foster community collaboration. So if you have sign up and then you have a Discord, please go to Discord and go to the introduction section, introduce yourself, and get to know each other because there are about 500 plus people sign up for this course. So at the same time, while you are learning, you also want to connect with people. And then when you come to the end of this 5th week, you probably want to do a capstone project, which is optional. You can find your team member, and then maybe you try to apply what have you learned for the past 5 weeks and do a capstone project. So at the same time, with this study jam, we also allow you to connect with the local AI experts. We want also to bridge the gap between people who are curious and people who and also build up the capability at the same time. Of course, we know that everything about learning is a lifelong learning. So we try to encourage people to learn, no matter what age you are, no matter what phase you are in your life. But if you want to learn, this is the best platform for you to learn. So this is the schedule you probably have seen. So week 1, we're going to talk about foundation model and prompt engineering. So week 2 will feature a topic related to embedding and vector store or databases. Week 3, Gen AI agents. Week 4, domain-specific large language model. Week 5, MLOps for Gen AI. And then week 6 or 7, you have a chance to do a capstone project. Okay, so for every week, at the end of the week, Saturday, we try to find speakers to actually give you a talk, which is about 2 to 3 hours related to the topic of the week. Of course, the topic of the week is very vast. You cannot just expect the speakers to cover everything in just 2 or 3 hours if you don't do all the assignment by yourself. Okay, it's impossible. So the talk is not to cover the whole week topic, but the talk is just for you to get a gist of the topic of the week. At the same time, you get to get support from the speakers. So this is how the study day will look like. So every week you have an assignment. So instead of doing one day, one assignment, now you have a whole week to do the assignment. Then every weekend, you will have a physical or virtual session. Like today, this is the end of week 1, where you are attending a virtual section. Okay, then there will be week 2, week 3, week 4, and week 5. At the end of week 5, then you can say you complete this GenAI study jam. And then if you still want to further apply the knowledge, you can do a capstone project, which is optional. Okay, like I said, please, the main objective of the study jam is also to build a community, to foster collaboration, to also make sure people come together and learn. So make sure you follow the Discord channel for all the announcements related to the study jam. At the same time, there is an introduction channel. Please go there and maybe introduce yourself, so get to know each other, what you're doing. And then later, you can actually ask questions. There's a lot of channel where you can ask a question, get the resources, get to know each other. So what is the reward for participant? At the end of the study jam, you receive a certificate completion. So at the end of 5th week, you receive a certificate completion. So make sure you have completed all the assignment. And then at the end of 5th week, the digital certificate of completion will be issued. So what are the resources? Like I mentioned, we have a study jam website. We have the Luma registration page. So the Luma registration page is actually for you to sign up for this study jam. At the same time, if you wish to attend the physical session at Sunway, you have to register. Why you need to register? Because the physical session is we have a limited space, so limited table and chair. Okay, if you want to attend, then you have to register. If it's already full, then you have no choice. You can attend the online. Every week we'll do the online and then the physical at the same time. Okay, then like I mentioned, please join the Discord channel to get all the latest announcement and also to get to connect with the fellow learners in this study jam. So this is how the schedule will look like. Okay, so we are in week 1 now. Okay, we are going to talk about foundation model and prompt engineering, which is going to cover by myself. Week 2 is going to cover about embedding a vector database, vector store and database by Professor Dr. Azam. Week 3 will be GenAI agents, will be Greg and Lifeform. Week 4 will be about domain-specific LLMs by Dr. Yu. Week 5 will be MLOps for GenAI by Christine T. Okay, then you have 2 weeks that you can actually choose to do a capstone project. Okay, more information about capstone project will be informed later. So for every week, what every participant should do. So every week, okay, there's a list of things that will be provided to you. You will probably have a podcast that is generated by the Noble LM. So you can actually watch or listen to the podcast of the topic of the week. Okay, of course, there are a lot of reading is provided. There's a hands-on assignment. You can actually do the Kaggle notebook. Okay, and then there's a lot of recommended white paper or resources related to the topic of the week. So what we have done at our side, we also curated some extra resources, maybe YouTube video, Reddit discussion, or some Medium or article posts that related to the topic of the week. So this is all these resources is actually to complement other material provided. So if you have time, please go through them, and we feel that the curated resources will enhance your understanding of the topic of the week. So during the program, what should you do? Okay, of course, as I mentioned, study jam, the objective is to get together and study the topic about GenAI. So make sure you study together online. And then if you have any question, okay, don't shy, go and join this discussion channel in the Discord. You can ask a question in the normal question, or you can start a discussion board where you can actually ask people to actually get response. Also, regular check-in. Make sure you follow up what is happening in the Discord to get any updates, whatever. So the purpose of study jam is to study together online. Okay, so make sure you we suggest the participant can study by themselves. All the material is provided to you. But of course, like I said, if it's an online study, a lot of time people will just drop off at the third week or the fourth week. So make sure if you want to study together, you should set a schedule. You also can actually, find a group that you can actually have a video call or using Google Meet or Zoom, whatever. Of course, always if you are curious or something that is bugging you, you're not sure, you can always discuss and have a Q&A session. Okay. So, like I said, this study jam we extended to 5 weeks. Why? Because we feel that we also want you to provide a support with the where you can contact to the physical or virtually through an AI professional. So you can actually host Insight Talk. We will host an Insight Talk for you. We'll invite experts such as MLGD or machine learning expert, okay, to help you while studying. So inside the Discord channel, we invited all these professionals to be expert. So if you have questions, if they are in the Discord channel, they will answer all your questions there. Okay. And then you should communicate in your communicating in your this language will be sometime if you're not very clear, you can ask some maybe in your own language. Maybe some people can understand the language can actually respond to your question. Okay. The one is a regular check-in. So make sure you have a regular check what all the information in the Discord channel. Make sure all the participants are able to complete the course. Okay. So you can actually for us as an organizer, will actually for every week at the end of the week Saturday you can meet the speakers. You can actually meet them, and then maybe you also come to the event, and also you can connect with other fellow learners at the Sunway University when you meet them. So there are other resources that's available. Later I will show you other slides. There are many resources also we have compiled. Some topics might not be just related to GenAI because GenAI is one of the topics in the vast topic related to AI. So in AI, you have data science, you have machine learning. So we have a lot of material that we have compiled. That's if you want to learn more, it's available at the next slide. For example, there are books, okay, that you can actually go through. Then there are online courses. Then there's other online courses related to machine learning, the foundation, and other courses that you want. And then there are other courses also. So, and let's say, and after 5 weeks, let's say you complete the course, what should you do? Okay. So of course, congratulations, you have completed the 5-week course. So then if you choose, you can actually submit your capstone project. So if you have completed a capstone project, you should submit this form. So through this form, you can understand what is the requirement to do the capstone project. Then what's the next step after you complete this 5-week course? Of course, like I said, learning is lifelong. So you can go and further other courses that are available that we have suggested just now. So you can actually go and do maybe more other competition in Kaggle. Then maybe you can also deepen your skill using all these collabs that's provided. There's also a Google Colab for Google Developer. Okay. Then if you want, you also can do certification related to GCP, Google Cloud Platform. Then there's other, you can try all the other Google model out there like Gemini, Gemma, and also be with Gemma. Or maybe you want to go further, you also can apply to be a GDE, Google Developer Expert in AI. So, so at the end, this is the purpose of the objective of the community. So, like I mentioned just now, this study jam is a event organized by the committee called the Artificial Intelligence and Machine Learning Malaysia, in collaboration with Sunway University, especially the Sunway Tech Club. So Sunway Tech Club with the students, they are organizing all the logistic, everything, and then with them, they are actually helping us to actually manage all these events related to this study jam. So if you want to know further, or if you're not connected with the AI ML Malaysia community, you can actually join the Facebook or in the LinkedIn. Okay, so I think hopefully with this brief introduction about the study jam, you have a rough idea what is the study jam all about. And then the main objective is to get Malaysian come together and learn about GenAI, and then at the same time build a good community and learn this GenAI topic together with the rest of the participants that have signed up for this course. Okay, so maybe I will stop for here before I start the next talk. Let's see if there's any questions. Okay, so far no question. Do you have any question you want to ask? You can type in the Q&A box. Can't join the Discord. Do you have a Discord link? Let me show you the Discord link. Okay, I think a lot of people having problem with the Teams. Okay, I think the main problem is because when you sign up the Luma, you use another email, and then now you are joining using your another email in the Teams, because the Luma, the link when you sign up in Luma, the link sent to you for the Teams is for the email only. Okay, so make sure you sign in your Teams using the link from the Luma email that you receive. Okay, if you click the link and then you sign another email, then you cannot join, because the link is only sent in via that email that you sign up for this course in the Luma. Any other questions? If not, then I can start with the next talk. Kingsley, you raised your hand. Do you have a question, or you just accidentally press? Can you type your question? Yes, throughout the course, the hands-on will be from Kaggle. Kaggle, the notebook is same like Google Colabs. Okay, it's the same. It feels the same. It's still Jupyter. It's Jupyter notebook. Yeah, if you have a question, just type your question. I can see in the Q&A. Okay, maybe you can ask your question, continue to ask if you have any more questions. I will continue with the next talk. So the slide is available here. Let me share my screen. Okay, so I will continue with the next talk. Okay, so the next talk is about the topic of the week. The topic of the week is about foundation model and prompt engineering. Okay, so as I shared already in the chat, the slide is available here, or if you have, if you want to use a phone, you can scan the QR code. Later, we also will share every week. The speaker slide will be shared in the shared folder also. We will share with you, don't worry. So, brief introduction myself. So my name is Kuan Hoong. You can call me KH. I'm currently working as a section lead for data engineering in data analytics in Roche. So I'm a Google Developer Expert, GDE, in AI. I'm also an AWS community builder in machine learning. So I'm very passionate about running communities in Malaysia. So I founded two communities, which is Artificial Intelligence and Machine Learning Malaysia, which is this event. Another one that I founded is the Malaysia R User Group. So if you are doing data science, you probably know that there are two languages people use out there. One is Python, another one is R. So in the R User Group, every year we have a big event which is called the R Conference. So last year we have it in the UCD Science Malaysia Kubang Krian campus in Kelantan. This year we are actually at the midst of planning for the event to be held at TAR UMT campus at Sapak, most likely around October or November. Okay, so if you are interested, you can actually click the link and join the Facebook page. Then when the event comes, you can get a notification. You can connect with me in LinkedIn. So I am quite active in LinkedIn. So if you have any question, if you want to ask me maybe career related to AI or the data science or machine learning, you can just contact with me in LinkedIn and ping me. So normally I will reply in a very fast manner.
I'm sorry, Dr. Pooh.
Yeah.
The slide is still on the slide 1.
Oh, okay. Why is it like that? Is it? Can you see my screen now? Only you or the rest of the same?
Just can see slide 1.
Oh, okay. How about the rest?
Yeah, the rest also saying the same.
Freeze. Let me try again. Stop sharing.
Hi, sorry, just some technical difficulties. Dr. Pooh, are you still there? I think he left the call, but he's going to be joining back soon. Sorry, I think we can take a small break while waiting for Dr. Pooh to come back. Seems that he's facing some technical difficulties right now. But we will resume shortly. Yeah.
Hello, can you hear me?
Yes, can hear.
Okay,
We're
I don't know
taking a
why
short
suddenly
break
my
while
camera
waiting.
not working. Let me share my screen again. Seems like these teams hang already. I don't know why.
Mm.
Okay, can you see my screen now?
Yes, can see.
Okay, let's see whether I can continue again. Okay, so week 1 slides, can see?
Yep.
Okay, cool. So as I mentioned, this is my introduction, connect with me. Can you see the agenda?
Yes, all good.
Okay, so I just continue. So the talk today will give you introduction about AI, machine learning, and Gen AI. Talk about introduction to large language model, foundation model, transformer model, and then the 3 important features in transformer model, which is embedding, precision encoding, and self-attention. Then we talk about prompt and prompt engineering, and then we'll conclude the session for today. So basically, what's AI? So artificial intelligence. So artificial intelligence is a theory and development of computer where it's able to perform tasks that normally require human intelligence. So you think something that normally human intelligence to do, this is what we try to do. We try to use the computer to see whether we can perform the task. Similarly, using this AI. So AI is a discipline, and then inside AI you have your machine learning, and then inside machine learning we have a more subfield which is called the deep learning. So when people say AI, that means you should know about some topic related to ML, machine learning, and then you also should know the more subfield, which is the deep learning. So machine learning, as the name machine learning, basically is to allow the computer to learn without explicitly programming. Okay, that means how does a machine able to learn? How? They may like human, how do we learn? We observe the environment, we actually read books, we read journal, we hear, we watch videos. So all these are information that actually we have to process by our brain to learn. But how the machine process information? So machine able to learn by providing data. So the data is a source of learning. So machine learning will learn from the source, which is the data. So by looking at the data, the machine will learn how does the data are connected and how does the data able to use it to do some sort of what we call prediction or forecasting. So that is machine learning. So when you do machine learning, there's 2 types of data. Okay, one is the label data. Okay, for example, I look at the data here. We have the amount of tips, then we have amount of total bill. Okay, so then we label data whether based on the total bill and total amount of tips given, whether the food consumed is either by pickup or by delivery. Okay, so the machine from here will learn that the data here, I have data about the value amount of the food that we consume, the total amount, and the tips given by the consumer. Then from there, we have the label data, whether the amount is pickup or delivery. Okay, so that is what we call supervised learning. That means your data has a label. Just like when you talk about cancer, so you have a cancer cell. Okay, so this of this patient have cancer or no cancer, or this patient have diabetic or no diabetic. So that's a label. Okay, so based on what you eat apple or you eat rice, whatever, whether the patient has diabetic or no diabetic. So that is a label data. Then there is data sometimes we have no label. Okay, so sometimes data no label, we do not know. For example, we just look at the income and the years of a person in the company. We do not know, there's no label. We just look at this data. Okay, so we want to see what's the relationship between the number of years and the amount of money the person make in the company. Then from there, we try to see what's the connection. Okay, so we try to find the correlation, okay, the connection. So this is what we call unsupervised learning. There's no data, no label data. Okay, so from supervised learning, you input your data into a model, then the model will learn, then you're able to do a prediction. Okay, this is what we call model training. You train the data. So for example, based on what you eat every day, okay, then I see the person whether he has diabetics or not diabetics. Okay, then I train the model based on what you eat every day for the 3 meal. Okay, and then the model will predict whether you have a diabetic or not diabetic. So this is what we call supervised learning. Unsupervised learning, there's no label. We just put in the model try to generate example. Okay, what is this relationship between the data? So after AI ML, we have another one which is called deep learning. So deep learning is another subset of machine learning. So like just now machine learning, we have supervised learning, which is label data, unsupervised learning. Then we have reinforcement learning, and then last one we call deep learning. So deep learning is actually what we call neural network. You probably heard of people say, "Oh, I do a lot of neural network." So all this neural network is the foundation, is the basis for all this generative AI. Okay, so generative AI are mainly use a lot of neural network, deep learning. So you can see this is what we call a neural network. Okay, so we call this artificial neural network because it looks like how our brain works. Okay, our brain, there's a lot of neuron. Okay, all the brain cell, they're all connected together. Okay, so based on all the data here, if you learn your math, remember y equal to mx plus c, your linear regression. So these are all your data that you put in. Then from there, your neural network to see what's the relationship with all the, we call this all this data point, and then they try to come up with the output layer. So this is an example of a neural network. So deep learning, you actually use what we call the artificial neural network, allow them to process very complex pattern of data compared to a traditional machine learning. So what is generative AI? So again, like I said just now, the most of the generative AI model out there, they use a lot of neural network, artificial neural network. So in a way, generative AI is a subset of deep learning. Okay, so why am I telling you all this concept about AI, ML, deep learning? And because basically, if you want to do generative AI, the foundation at the back, okay, they are all using neural network. So as the name mentioned, generative AI. Okay, so generative AI is a very unique type of AI. Why? Because it has this word generate. Okay, it has this word generate. That means now AI, this AI now, okay, is not just able to understand, okay, the data. It's able to take the data, understand it, at the same time, it's able to create new data, or we call it new content. For example, now we use ChatGPT or Gemini or Cloud or whatever. When you ask it something, it's able to generate a text for you. So that is a text generation. Or you use what we call, for example, this DALL-E, or we use Gemini now, or Midjourney, able to generate images for you. How does the AI learned to generate image, he has seen billions of images. He has seen the relationship between the text and the image. So when you give a prompt, to the model will understand what you want and able to synthesize or generate new images based on the prompt. The same thing now, you can use the GenAI to generate new sound, new audio, okay? And you can actually use it to generate new video, okay? Like in ChatGPT, OpenAI have this Sora, and then this Google have Veo 3. These are all the tools available to actually generate new video. So with generative AI now, you can generate text, you can generate images, you can generate audio, and you can generate video. Okay, so when you look at the deep learning model, remember just now we said that generative AI is a sub of deep learning. So usually there's two type of model that's inside this deep learning model. One is called discriminative. Discriminative basically is to do classification or to predict. Okay, for example, I give you an image of an X-ray. Okay, then the AI will look at it. Oh, this X-ray has a cancer cell or no cancer cell. That means it's able to classify or able to discriminate whether the cell is cancer or no cancer. Okay, so when you want to do all this discriminative model, then you need to tell the model, you train the model by using label data. Okay, so that means you show a lot of images, for example, cancer, images of X-ray. You say, okay, this is how a cancer cell will look like. So after the model gone through many images with how a cancer cell will look like and how not a cancer cell look like, then when you give a new image with no label, you're able to understand, able to predict, or able to classify, okay, whether the image is cancer or no cancer. Okay, so now in the discriminative model, you're able to learn the relationship between the features, all the images features, and the data point and the label. So for example here, you can actually learn to separate whether if a data fall in this side, this is green, or whether the data fall in this side, this yellow. So let's say a new data point, I fall in this side, then this data point will belong to the yellow data points. If a data point fall in this side, then it will belong to the green data point. So for example, if I show an image, the image seems like fall into this side, then maybe this is a non-cancer cell. Okay, so that is a discriminative. Now with the same deep learning model, you can actually do generative. Generative means you're able to use all the data that you have seen, the model, you're able to generate new data point. Okay, so this is where you say just now, you show a lot of picture or show a lot of text, then the model able to understand the relationship of the text. Then when you give a prompt, we ask it to write a email reply or ask it to write a novel, okay, because he has seen many texts already, then he can generate new text for you. Okay, so he understand how the data are distributed and able to given some example and able to predict the next word in the sentence. So discriminative technique, basically, if I show a picture, after the model learned seen many picture of a dog and a cat, now if I show a picture of a dog, able to say, oh, this is a picture of a dog. Okay, so this is what we call discriminative method. So this one is very useful. We have seen many times already. For example, people build like, oh, this is a picture, this is a cancer cell or non-cancer cell. If it's a manufacturing, you can show a picture and say, oh, this is a product, defect or no defect. So these are all discriminative technique. With now generative, I show a picture of a dog. Okay, now I can generate new picture based on this dog. I can generate a new picture of a dog. Okay, like now you probably have seen people like in OpenAI, ChatGPT, you upload your picture, then you say, can you change the picture into Ghibli style, Ghibli Studio? Okay, that means based on your picture, you understand that you want it to be a Ghibli Studio picture, you're able to generate a new image for you. So, how do you know whether it's GenAI or non-GenAI? when your y, okay, when your output is a number or discrete value or a class or probability, then this is not GenAI. This can be a normal discriminative. When I want to predict a class, okay, then this is not GenAI. GenAI means you generate new data point. Okay, when your y, you generate a text, a new text, or you generate a new image, or you generate a new audio, then this is GenAI. If your y, the output is just a number, for example, the next week sales is 2,000 ringgit, then that is not GenAI. Okay, or the next week the prediction, okay, is class A, okay, then that's not GenAI. Okay, or probability, then that's not GenAI. So GenAI is something which actually generate a whole sentence, generate a new image, or generate audio. So GenAI can be supervised, semi-supervised, unsupervised. Remember, supervised means your label data. Okay, semi-supervised, you have a mix of label, no label data, and you have unsupervised, totally no label data. So you provide tons of data into your model. Okay, whether got label data, unlabeled data, or just programming code. So basically, then you learn all these data points. Okay, then you can actually use the same model learn to generate a new text, or to generate a new code, or to generate a new image. Okay, so this is GenAI. Okay, so you can actually see, for example, if I ask the model to learn all the books out there, so books is no label, isn't it? It's just books, it's just text. So those are all unsupervised. Okay, so you also can put in data point like medical research, cancer cell or non-cancer cell. Then that is supervised label data. So in generative model, you have what we call generative language model. This will generate new language. So generative language model basically learn the patterns of the language. Okay, so remember our language, our sentence has a lot of structure. You have grammar, we have what we call this verb, adverb, we have pronouns, nouns. So after you feed in tons of text, it's able to learn the patterns. Okay, so when you give a prompt, when you give a text, it can actually predict the next text for you. So this is generative language model. So when we talk about LLM is example of generative language model because it's actually to predict, to generate the language. Then we have generative image model. So generative image model basically is to generate new images. Okay. So after you learn, after you've given many billions of images, okay, you're able to produce new images using a technique like called diffusion model. Okay. So most of the model out there to generate images is based on this model called diffusion model. Okay, so you give a prompt, okay, and then you give a little image. You can transform the image into a new image and generate the image from the prompt. Okay, so you can actually generate image based on data. You can put an image, then you can actually. So now instead of putting a prompt, you can upload an image. Then from there, what can you do? You can understand what's inside the image. You can do an image captioning. You can also ask questions. Okay, what can you see in the image? He can give you answer. Okay, or you can actually search similar images. Of course, once you've seen the image, it can generate new image for you, or you can actually improve the resolution. Okay, of course, from the image now, you also can transform the image into a video. You can animate the image. Okay, for example, here I can actually replace the cherry with the oranges. Same here, I can replace the person on a skateboard and generate a new image of a dog on a skateboard. So another way that you can actually input is using text. This is the normal way that we interact with the large language model. We just type a prompt or text. From there, you can do translation, summarization, Q&A. You can correct the grammar. You can actually use the text to generate new image. Okay. generate a text-to-speech, generate audio, or you can actually maybe transform the text into maybe to a code, or maybe you can generate a games. Okay. So you can see here we can generate images now. You can use like DALL-E tools, all these image tree in Google. You can just give a prompt and generate image for you. You can use Midjourney, same. You can generate all the images. Okay, so in Google, you can go Gemini. So Gemini, the latest model is 2.5. So if you use a 2.5 Pro, okay, you can actually select that you can use the, for example, this canvas screen here. There's features here. You can ask it to generate something like an interactive mode inside the canvas. Okay, so what is large language model? Okay, so what is large language model? So large language model basically is a machine learning model that is trained with massive amount of data, which is in the form of text. Okay, so large language model is another example of a generative AI. Okay, so you have ML, deep learning. So inside deep learning, you have GenAI. So GenAI, one of the GenAI is the large language model. Okay, it's very specific to generate language. Okay, so what is large language model? Basically, it's a very large, very general purpose language model that can be pre-trained and fine-tuned. So what is a pre-trained model? So when you train the model with huge amount of data, okay, you basically have trained a dog. Okay, so what a dog basically can do, you can ask the dog to sit, come, down, and stay. So this is a common command. So when you have a dog, you expect your dog to have to understand these 4 commands, basic commands. But sometimes, okay, so if your dog can actually understand these 4 basic commands, so it's considered a good dog. But sometimes you want to train your dog for a specific purpose. For example, you want it to be a special service dog, like a police dog, or you want it to be a guide dog for blind people, or you want the dog to help you to do hunting. Then your dog needs to learn new skills. So this is what we call fine tuning. Okay. So for example, large language model, if you go to ChatGPT or you go to Gemini, you can basically do most of the things. But the ChatGPT or Gemini doesn't understand the data related to your context or maybe your company data. Then maybe you need to fine tune the model with your company data so the model can understand the context of the company. Then you need to do special training. In the large language model, this is what we call fine tuning. So basically, large language model, similar idea can be applied. So large language model, you can train it now, you can actually do some fine tuning, then you can actually do the text classification, question and answer, document summarization, text generation. These are all basic. Okay, all the large language model can do. But sometimes you might want to tailor it to very specific field. For example, you want it to be able to answer in the context related to retail or finance or entertainment. Then you need to provide very a small size of the few data set, and then you can fine tune your model. So for large language model, basically it's large. Why is it large? Because it trained with large data set. It has a lot of parameters. So what is this parameter? This parameter is related to your neural network just now. So when you have a lot of parameter, that means your neural network is very, very complicated just now. Then most of the large language model is very general purpose. Okay, it can understand human language. It has a resource restriction, but sometimes you can use the pre-train, which is normal train model, or you can fine-tune your model. So basically, when you train your model, they can actually do all the basic tasks. This is what we call foundation model. So foundation model basically is a model that trained with all the data available out there, whether it's a language data, text data, or image data, or video data. So the foundation model is multitask, it's very large scale, and you don't need to do any more training because it's already pre-trained for you. Okay, so you have a lot of data in the form of text, images, speech, structured data. You can train it, then you have a foundation model. Then from the foundation model, you can adapt it. Okay, for example, you can do Q&A, text. You can do image captioning, can understand image. You can do object recognition. you can actually do coding. So you can actually make it to specialize into a certain task based on the foundation model. So what's the benefit of using large language model? So benefit is a single model now can be used for different tasks because it's already pre-trained. Now you can fine-tune your model if you want it to be able to require to serve a very specific field of data. And then you can continuously improve your model, okay, as you go along. Whenever there's an improvement on the model, the foundation model, then your performance of the model will improve, okay? Then if you want to, when you have a new data related to your, specific to your context, you can do a further fine-tuning. Okay, so how does this model work? Okay, how does this model work? Okay, of course, most of the model now you have already been trained. Okay, so for example, if you use the open source model, for example, Meta, it has released an open source model called Llama. So Llama, the model, when you can just use it directly, you don't need to do anything. So those are called pre-trained model. Okay, so pre-trained model, that means the model already been trained with large amount of data. It has billions of parameters. So if you go to like the Llama, you can say, oh, this is 42B. Okay, what does it mean? 42B means you have 42 billions of parameters. Okay, that's inside the neural network. And most of the data is unsupervised learning. That means there's no label data. Okay, one good example of no unsupervised learning is all the text data. Text data like novel or scientific paper or newspaper or report or blog post. There's no label. So those are called unsupervised learning. Okay. So for example, you ask a question, how is it going? You input into a model. So the basic model in all these large language model, when you train it, is what we call the transformer. So later I explain further what is transformer. But basically, it actually do two things. One, it encode the text, then it decode the text. Okay. So you have these two processes, encoding and decoding. Okay. So you encode the text and then you decode the text. So by doing the encoding and decoding, you understand the structure of a sentence. Then you learn, you understand that later you explain that you understand this sentence, what you try to ask. What is the context of this sentence? Then he will save all this into a form of a parameter, which is called, that's why it's called pre-trained. Okay, pre-trained transformer model. So generative pre-trained transformer is what we call the GPT. So it's short for GPT. So when you say you use Chat GPT, the word GPT is stands for generative pre-trained transformer. That means it's already the model is already be pre-trained with large amount of data and using the transformer model. Okay. So when you ask a question like how is it going? So now the model already trained that if I get the input and how's it going, my response supposed to reply back that to this how's it going response. So the model already been seen many response that from the question how's it going, what will be the next most possible response. So most possible response probably have seen as, oh, I'm doing all right, thank you for asking, how are you? Okay, then he will generate this text for you based on what you have seen many texts before that. Okay, so a pre-trained model looking at the input of text is able to predict the response and generate the sentence for you. Okay, of course, sometimes like all the other model, sometimes the text will generated is not correct. Okay, and it doesn't make sense. So when the text generated by a large language model, which is not correct or doesn't make sense, in large language model, this is what we call hallucination. Okay, because why? Because some of the model they are being trained to respond no matter what. Because most of the model is better to respond something than not respond anything. So the model are very eager to generate a response, even though the response might be wrong. Okay, so in this sense, this is what we call hallucination. Okay, so this is very important. That means hallucination will happen everywhere as long as you're using large language model. Okay, so hallucination is where you generate something that is nonsensical, or even grammatically incorrect. Okay, so as a user, you should check your response generated by the large language model. Do not blindly just copy and paste the answer without checking, because hallucination is always there. No matter what the model said is how many percent accurate is a model, but they still cannot completely eliminate hallucination. So what is the challenges of hallucination? Okay, of course the challenges is sometimes the model is not trained on enough data. Okay, what does that mean? Okay, when the model is trained, there is a cutoff date. For example, now is June. If the model trained until now, June, today, it will not know what is happening yesterday and the day after today. So when you ask a question, something that has not happened, the model might not know, but because the model is very eager to respond to you, he'll generate something that is not true. Okay, so that is what happened. Okay, that's hallucination. Sometimes the model is also trained with noisy and dirty data. Okay, so for every company, whether it's OpenAI or Google or Microsoft or Anthropic or any other company that are doing large language model, they actually spend a lot of money to clean the data. Okay, that's why when you want to train a model from scratch, okay, for example, like ChatGPT, when they launched the first chat, which is ChatGPT 3.5, it cost them about like 100 millions of USD to actually train the model. A lot of time, it's not just about training the model, it's also a lot of money spent on pre-processing the data. Okay, sometimes the model is not given enough context, and sometimes the model is not given enough constraint. Okay, so when the model nowadays, whenever any model is released, most of the company we have a guardrail. So the guardrail will prevent the model to respond something which is inappropriate or something that is not correct. Okay, so most of the time, most of the model have a guardrail built in that will not allow you to actually generate something that is not correct. Okay, so like I mentioned just now, the important component of the generative AI for the pre-trained model is the transformer model. So what the transformer model will do? So the transformer model basically will do two things. Okay, he take in the input, he'll encode the component, then he'll try to decode the component. By going through encoding and decoding, he can understand the structure of the sentence, okay, and he can understand what is the sentence all about. Okay, for example, I can input a French word, je suis étudiant, that means I'm a student. Okay, then the output, if it's a translation, you output that I'm a student. Okay, because he has seen through many data, okay, in the text data in other languages, he know that this data is correspondent to the English version, which is I'm a student, able to respond to you. Okay, so the transformer model is actually based on the paper published by Google. The paper is called Attention is All You Need. Okay, so the name is very corny lah. Basically, attention is all you need to tell you that when you have a sentence, the model need to understand where is the attention, where the model need to pay attention in the sentence. Okay, later I'll show you. So basically, this paper was published, so there's a typo here. The paper was published in 2017, so about 8 years ago lah, by Google. You can see all the researchers here are all Googlers. Okay, so this is how the transformer model, original model look like. He has the two things, which is the embedding and which is the encoding and decoding. And then there's three things you can see here: embedding, positional encoding, okay, and then you have the attention. Okay, so you can see all these feed forward. What these feed forward? These are all neural network. Okay, all neural network. So the three important concept of a transformer model, later I explain, is the positional encoding, then the embedding, okay, and then the attention. Okay. So basically, if you see that after the transformer model came out published in 2017, Google has launched a few models, precursor to ChatGPT. So we have all these BERT, GPT-3 or Cloud. They are all based on the transformer model. Okay? From the transformer model, you can do like chat conversation. You can use the data like a foundation model to generate new code. You can do a data text summarization, or you can actually generate new sentences or paragraphs. So how does the transformer model work? Okay, so large language model are trained on the vast amount of data. Okay, so when you feed in a lot of data, all the text data, okay, what the model will learn? He will learn the patterns and structure of the language. As you know, when we learn a language, no matter whether it's English or Chinese or Japanese, any other language, it has its own patterns and it has its own structure, the grammar. Okay, so for example, English, they say I play ball. Okay, so if you're Japanese, you become I ball play. So the object and the verb is reverse compared to English. Okay, so for every language, it has its own patterns, it has its own structure. So before transformer model, last time, people study language, they do something what we call NLP. NLP stands for Natural Language Processing. So what they do, they will actually label, or this is verb, this in this sentence, this is a verb, or this is an adjective, this is a noun. You have to label. Okay. Now with transformer model, the model will learn the patterns and the structure in the language. Okay. So the large data process will help with three components. So this is, I mentioned just now, the three components that make up how the transformer model works. Okay. So the first is embedding, second is position and encoding, and third is attention, self-attention. Okay. So large language model excel in understanding and generate human-like language. Okay. Early model treated word as character sequence. Okay. So all the model before transformer, people just look at character by saying character. But this doesn't work because if you have a very long sentence, then the model will lose the understanding of the structure of the sentence. With transformer model now, you have no problem, okay, because of the three components: embedding, positional encoding, and self-attention. Okay, let's look at the first component, embedding. Okay, what's embedding? Okay, embedding will convert the word into a number. We call embedding. Okay, remember, computer at the back can only understand numbers. Okay, remember our computer can only understand bits and byte. Okay, 0 and 1. 0 and 1 are all numbers. So no matter whether you input image or no matter you input a word or text or character, still need to be converted into numbers. Okay, so the number converted from text or word is called embedding. Okay, what's so special about embedding? Embedding, if you have a word with a similar meaning, they will have a similar location or similar numbers. For example, apple and banana, they are all fruits. Then the number in the embedding space should be closer for banana apple compared to spaceship. Okay, why? Because when I have a number closer to each other, okay, when I have something like this, apple and what are healthy food options. Okay, so for here, when the large language model want to predict what is the text inside here, you will find the text, okay, which is closer to apple. Okay, for example, here, banana will be a good answer compared to spaceship, because spaceship, in terms of similarity, they are not similar. So with embedding, now you can actually capture complex relationship in a language. Okay, you can see all those words has a similar meaning, will have a closer numbers embedding space. This will reduce the dimensionality. You can train your model faster, and then you can have a smaller model size. So you have all these unsupervised pre-training. Okay, you can do all the classification and summarization later. So what is embedding? So embedding basically is to make easier for you to a model to associate word with similar meaning by identifying similarity in the vector location. So for example, tea and coffee, both are drinks. So they are anything that is a word that's similar or might be related to tea or coffee. You can have breakfast, you have drink, or enjoy. So these three words maybe will have a closer embedding space, okay, to each other. But then you have T and P, okay. So the T and P here might sound the same, okay, because one is start with T, another one is start with P. But because one is a drink, one is a vegetable, they are not very close to each other. So therefore, they should not have a closer embedding space. Okay. So when you want to encode this, when you want to put them into embedding space, maybe the distance between tea and coffee is only 0.3. But the distance between coffee and P will be further away, 0.7. Okay. So for example, you have diabetes, hypertension, ACL, tear, high blood sugar, high blood pressure, and knee injury. Okay, so you can see diabetes. If we human, when we look at this, which one can be grouped together? Maybe diabetes and high blood sugar can be grouped together because they are some sort of sickness. Hypertension and hyperpressure can be grouped together because if hyperpressure is similar to hypertension, then ACL tear is an injury in your leg compared to knee injury. So they can be closer together. So when you look at this, here you will see that the relationship between diabetes and hyperpressure should be the same. There can be the similar embedding space. Hypertension and hyperpressure should be the same or should be nearer embedding space. SCL, tear, and knee injury should have a closer embedding space. So when you plot them out, this is what we call the vector embedding space. These two data points are much closer to each other. And these two data points are closer to each other, and these two data points are closer to each other. Okay, so this is how when the model learn, okay, when you want to predict the next word, you find the word with the closer embedding space. So we're embedding, it review a deeper relationship between the word and the text. Okay. Okay, I will finish positional encoding, then we can take a 10-minute break. Okay. So next important component of a transformer model is called positional encoding. Okay. So positional encoding has the name imply the position of the word in the sentence is very important. Okay. The position of word in the sentence is very important. Just like I mentioned just now, in Japanese, if in English is I play ball, in Japanese it's I ball play. Okay. So how the word, where is it positioned in the sentence is very important. By doing embedding, it does not give you the information about the word, the order of the word. Okay, so when you want to train a model of a structure of a sentence, you also need to tell where the word is stored in the sentence. Where? So this is where we call the positional encoding. You encode, you also pass along the location of the word in the sentence. So the positional encoding will add extra information where the word in the sentence. Okay, for example, the hat sits on the table. It's not the same as at the table sits a man wearing a hat. Okay, so it sounds the same, but in this case here, the table has a hat. In this case here, the table, there's a man wearing a hat. Okay, so the table here is the location as is on the for this example is at the third word. For this example is on the 1, 2, 3, 4, 5, 6, the sixth word. So the word table here, even though it is both appear in two sentences, the location it matters. Okay, so the positional data will differentiate similar words in different contexts. So it provides certain context, okay, for the model to understand. And this helps the model learn about syntax and context. Okay, so positional encoding help the model to learn the word order and the position of the word. For example, let's say now the hat sits on the table. So the table here is on the sixth, the last location. of the sentence. Okay, so you can see the head. Okay, maybe the head here. Okay, now you can encode the location. Then you can see this is how you encode. Then you can have another sentence. At the table sits a man wearing a hat. So the hat here is at the location 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, so you can see the table here, but the table is here. The seats here and the seats here is different, and the hat is here. So by this, the transformer model able to understand the context of the word and where you need to pay attention. Okay, where you need to pay attention of the word. Okay, so maybe I take a 10 minutes break here before I continue with the attention. Shall we take a 10 minutes break? We come back at 11:40.
Yep, can.
Okay, shall we continue? Okay, so we continue with the third component of the transformer model. Okay, so as mentioned just now, in the transformer model, you have something what we call embedding. So embedding allow you to actually encode those words that have a similar meaning or similar context in a closer embedding space. Then you have positional encoding. You also pass the information about where the word is appear in a sentence together into the model. So the model able to understand the context and structure of the word. The last one, the component of transformer model is called the self-attention. So self-attention is the important innovation in the transformer model. That's why the paper is called Attention is All You Need. Okay, so by looking at the sentence, by looking at the word, where the word is, the model will pay attention to the word which is relevant to the context of the sentence. Okay, so this is very important. Okay, we allow the model to attend to all the words that they input where which of the word is most relevant in the sentence. Okay, that's like how we read lah. When we read a sentence, okay, we focus on the word that's important for you to understand the meaning of the word. Okay, so with attention now, you're able to understand the context, okay, and differentiate the meaning of server. Okay, so we know server can be someone who work in a restaurant. For IT, server can be a server room. Okay, can be a computer client server. Okay, so this kind of context, even for a human, we able to understand by looking at the structure of the sentence. So this is also very important because the model should be able to differentiate in this context. This server is referring to a machine, or this server is referring to a human. Okay, that's very important. Second thing, with attention, the model also will learn, okay, what are the words is actually what we call synonym to each other. You have the developer is similar to programmer, can be similar to a software engineer. Okay, so sometimes with attention, it also allow you to handle anything that is not clear or what you call ambiguity. For example, a crane. A crane can be a bird. A crane can be a machine. Okay, so in this sense, the model able to understand and pay attention because the crane, if in a sentence, is it referring to a bird or is it referring to a machine? Okay. At the same time, when you have this attention, you're able to understand the context of grammar, the gender, all the tenses. Okay, you can able to understand that. Okay, so sorry. So with attention, sorry, let me. Oops, sorry. I need to share again. Sorry. Okay, so with attention now, you have the component of attention with embedding with the position encoding, then you have a better understanding of the structure of the sentence. So self-attention is where the model pay attention to the words that provide the most context. So for example, the model will able to understand a programmer is actually can be synonymized with a software engineer, can be also same as developer. For example, if I ask you to create 5 fictional names for airline pilot, Okay, so you can actually just come up with any name. Okay, for example, Susan, Peter Woods, Wendy Allen, Arthur William, or Julie Miller. So for this case here, the data provided for all the airline pilot, okay, so the pilot can be a male or female. It will not just create name that is not only certain gender centric. For example, if I ask a question, how do I ask a server to bring the check in French? So for human, we know the server here means because you say you want to bring the check. So this server here will refer to a human. Okay. But then if you ask another sentence, provide instruction in French, how to check the server hardware. So because there is a hardware here, you know that this hardware is referring to the server. So for this case here, you will know that this server is a machine, this server is a human because you ask for a check. So this is where the precision encoding, the embedding, and the attention will help the model to understand the context and differentiate between this server and this server for these two sentences. So for this server, because you say ask and you say check, and he will know that this server is a human. For this case here, when there's this server, because you say check, okay, even though check is also appear in both, but you say hardware here. So you will know that this server is referring to a machine. So for this case here, server is a computer. So this server is a computer. So another example here is where we say we also can have ambiguity. That means something that is not clear. For example, the bridge by the river is where the crane lives. So for this case here, this crane is referring to a bird. Okay, because live, the word live here and the bridge and the river. Then there's another sentence. The crane is building a bridge by the river. So you can see here, there's a bridge here, there's a bridge here, there's a river, there's a river. But for this crane here, it's referring to the machine because you are building. Okay, so this where the model able to differentiate. This is you're asking for a machine. This one you're asking for a bird. So if you feed these two prompts into the image generator, for this one, you're able to understand they are asking for a bird. So you generate the image of a bridge and there is a crane. For second one, you will say you want it to, the crane is building a bridge by the river. Okay, so you are asking for a crane, there is a machine. Then he will generate a bridge here, image, and then there's a crane here. Okay, because he know that you want a machine, that an image of a machine on a bridge by the river. Okay, you can see, even though for us human, we look at this, we understand the context. So you can now, with the transformer model, based on the three components, the embedding, the precision encoding, and the attention, you're able to provide context to the sentence and able to understand the sentence. Okay, so this is the differentiation. Last time, if you are a programmer, if you want to tell a machine, how does a cat look like? You need to define all the attributes of a cat. So you say, oh, it's an animal, you have 4 legs, you have 2 ears, you have fur. You need to type all these things. Okay, so you need to define all these variables. Okay, so if you're a neural network, you don't need to type anything. Okay, you just put all the data, image of a cat inside. So this is a cat. This is not a cat. So you feed in more and more all these data images, then the neural network able to learn how does a cat look like. Okay, you don't need to define whether it got 4 legs or 2 ears or fur, whatever. Based all the data feed into a neural network, the neural network able to learn the concept of a cat, and there's a concept not a cat. And then when you show a picture of a cat, you will know that, oh, this is the picture of a cat because it learned by itself. Okay, the concept of a cat and what is the attribute of a cat. Now, with generative model, language model, not just able to differentiate whether it's a cat or not a cat, it's able to take an image of a cat and even tell you a new picture or generate a new picture of a cat. So you read a lot of books, all the text data, He read a lot of, he's shown a lot of picture of a cat, millions of picture, and then he understand the concept of a cat. Now he will ask you, if you ask a question like, what is a cat? He's able to learn from all the text, all the images. He's able to learn the concept, what is a cat is all about. He can give you, a cat is what. Okay, so this is where we say, based on all the data learned, you're able to understand the concept. That's where you say you build a pre-trained model, or what we call the foundation model. So compare a large language model, compare a traditional programming. So large language model, you don't need to actually have expertise in machine learning. You don't need to have example. You just feed all the data inside, and you don't need to train a model like what we do in the machine learning. But you still need to pre-train the model. Then you just need to think about, just use a large language model. When it's a pre-trained, you just think about the prompt. For traditional programming, you need to have a machine learning, you need to train a lot of example, you need to actually train the model, and then you need to train the model, use a lot of computing time and hardware. Then you need to think about how to make the model more accurate. Now, with the large language model, you just call the API, and then you just use all the pre-trained model. Okay, next we talk about prompt. So what is a prompt? Okay, so a prompt is the input into the large language model. So basically, you need to input the large language model to actually ask the model, the model to generate the response. So when you want to generate a prompt, we call it prompt design. So prompt design means the process of creating a prompt to make sure the model responds to the desired response that you want. So what is a prompt and prompt engineering? So prompt design basically is an instruction or context passed to the large language model to achieve certain tasks. Whereas prompt engineering is the practice developed to optimize your prompt to efficiently to use the large language model for different applications. So even though people say you just enter text, why is it called engineering? Because it's engineering means you need to think about how to best use the prompt and need to have a strategy to make sure the prompt able to get the result that you want and make sure it's very effective and very efficient. Why it need to be efficient? Because when you call a model, especially when you call a model like all this Gemini or ChatGPT, whatever, you actually basically you're passing the prompt. If the prompt is not efficient, every time when you the model generate response, it actually costs you a lot of money. Okay, and then you also want to keep on passing the prompt, because every time the model generate response, it costs you a lot of money. Okay, so you want to think about what is best way to optimize your prompt and what's the most efficient way to use the language model. So there are 3 types of ways to prompt the large language model. The first 2 are very easy to confuse, will give you different output. One is the language model. This will predict the next text. So basically, a large language model, how does it work? The large language model, when you ask something, you just predict the next text. Okay, so they predict until you form a sentence. So a very generic large language model basically is just a next word predictor. You just predict the next word until a sentence is generated. For example, if I put in when the model generate the response, the cat sat on, so you have a few possible answers. Okay, so when you input the model will go through, and then remember you need to encode this input in what, and then you need to pass it to the model. So when you pass all this, you need to pass into numbers, and then all these are called a token. Okay, so when you pass a word into your large language model, it can be considered 1 token. So the large language model, then you predict every token is a word. Basically, it's a basic unit of the large language model. Then what he will do? Then he has a list of possible words. Okay, that he will that can actually form the next word. So for example, it, whatever. Okay, so what happened here is he will predict a list of a word, then you choose the word that has the highest probability to be the next word. So for this case here, the most likely word is the. Then you have the and then go back again, you predict the next word. And then this will be the next most likely word. And then these are the least likely word. Okay. So the vector representation will actually show you what is the most likely word, and that there will be, and then you go through again. The next type of prompting is called instruction tune. Instruction tune, basically you train to predict a response given instruction to the input. Okay, for example, this is the instruction tune. So the instruction tune means basically you can give certain instruction. For example, for every large language model, you can do summarization, you can ask it to generate a poem, you can give it a certain keyword, and then maybe you want it to generate similar things. So based on this, you have given certain instruction, then the large language model take in the input or the prompt, and then he will give you the output. Okay, for example, you want to classify the text whether this is a neutral, negative, or positive. This is the instruction. Then you give him the text that I think the food was okay. Okay, so based on the instruction, then the large language model will give you the output. Okay, so this where the instruction was given, and then you want the output. Based on the output, then the model will predict the output. So for prompt, there are a lot of prompting tips out there. So of course, you will want to talk to the large language model. Basically, you need to use a natural language. Talk to your large language model like you talk to a colleague. Make sure it's clear and concise. Make sure you provide context. The better the context you provide, the better the model will understand. Make sure you need to use specific keywords or relevant keywords, because the model will understand your request and able to create a better, accurate response. Sometimes it's better to break down your task into separate prompts. Okay, for example, write me a job description for data engineer. Okay, that could be a first prompt. Then after that, you say, okay, after the response generated already, the job description, maybe you can say the job description should be for a company for data engineer related to telecommunication. Okay, then from there you refine the output to focus more on data telecommunication. So you don't need to put all the prompt into one. You can iterate, and you can break the task into separate prompt to actually slowly guide your model to produce the result that you want. Okay, so how to create a useful prompt? Okay, so if you have been using a large language model, sometimes you might not get the result that you want. So what's the 4 main area to consider when you write a prompt? First is a persona. You can ask the large language model to play a certain persona. For example, you say, you are a 15 years marketing director. So the prompt now, the large language model will play a role of a marketing director with 15 years experience. Or you can say you are artist, the create lyrics, hip hop lyrics. Then the large language model will play a persona of someone that can write hip hop lyrics. That's the first thing. Second thing is you must tell what the task the large language model need to perform. Okay, what you want it to do. Third, provide some context. Okay, for example, like I said, data engineering for telecommunication. So certain context. And lastly, you want it to be output, what kind of format? It can be an email, it can be output in a table, it can output as a novel, depend on the output that you want. Okay, for example here, draft for executive summary email. So you want to have an email, draft an email to someone based on what relevant program, and then make sure you want it to output as a bullet point. So you can see here, I can break it down, my task, my persona, and my format. Same here. I want to write a closing statement about expectation for everyone to contribute respectful welcome workspace using a professional tone. Okay, so you want this is the prompt that you want, and make sure you follow if can make sure you follow these 4 main areas. So basically the 4 component is persona. tell the large language model what role or how you should respond, and what is a task. So tell the large language model what you want to do or create. Context, provide as much context as possible, background, and maybe the last one is a format. So you need to specify what are the format that you want. Can be email, can be a bullet point, can be a report, okay, or can be a table. So you define the format. Okay, last one is the large language model where you can actually what we call dialogue tune. You train to have a dialogue by predicting the next response. So dialogue tune model are especially case instruction where you can actually frame it as a question to the chatbot. So dialogue tune is further specialization of instruction where you can actually back and forth is like a conversation, and is this what is work? It actually work better like a question answer kind of question. Okay, for example, is the comment, do you like the weather or okay or toxic? Okay, so you ask a prompt, okay, then you give instruction, then the large language model respond that, do you like the weather is not toxic, so it's okay. Then you ask again, can you briefly say why? So in this kind of conversation, you slowly guide the large language model to output the response that you want. So it's just a question about whether people are usually not upset about that. So you can see now from here, you can actually get an understanding why the model is giving you the response of okay. The next one is what we call chain of thought reasoning. So if you look at most of the model out there, whether you use Gemini or whether you use this ChatGPT, it has what we call reasoning model. Like DeepSeek now all have reasoning model. So the reasoning model, okay, basically it has what we call chain of thought. So chain of thought is just like similar like how we human think lah. Human, we have train of thought in it. Okay. So the train of thought in the large language model is able to ask the large language model to break it down the output and ask the large language model to think before they respond. Means maybe you ask them to think about and explain the reason why they output this output. So with this way, before they output, they think first. This way is more likely for them to explain the output and also guide themselves to give you the correct answer. Okay. For example, Roger has 5 tennis balls. He buy 2 more cans, and each can have 3 tennis balls. How many tennis balls he has now? So we know, so it should be 3 times 2, 6, 6 plus 5, okay, then it should be 11. So human, we think like that. So you expect the model should be able to break down this prompt, able to calculate and able to think before give you the result. So now you say, instead of giving the answer, you ask him to think through step by step. So when you ask him to think through step by step, this is where you apply, the model will apply the chain of thought reasoning. So you say, okay, Roger have 5 balls, 2 cans of tennis ball, and 6. So you say now you understand that 2 cans will be 6 balls. So 6 plus 5, okay, will be 11. Okay, typo here, it should be 11. The answer is 11. Okay, so you can see most of the model out there, whether you use DeepSeek or Gemini or this ChatGPT, now if you ask him to think through, he will go through this chain of thought. Okay. Next one is that's how we briefly go through a bit. We call tuning. Okay, we call it tuning. So what is tuning? Tuning basically you adapt your model to a very specific domain or a very specific use case by training your model to a new set of data. Okay, this doesn't mean you need to train your data from scratch. You just take a small set of data and you tune the large language model with the new set of data for specific purposes. Okay, so this is what we call fine-tuning. Fine-tuning means you bring your data set and retrain your model by tuning some part of the data model. Okay, and then instead of training the model from scratch. Okay, so this is called fine-tuning. For example, you have a healthcare data. Okay, if you use the normal pre-trained model, maybe the model will not able to understand healthcare data because he have not been trained for healthcare data. Now, let's say you have a healthcare provider, you can provide some healthcare data, and then you can fine-tune your model. Okay, so you can build a medical foundation model, then you can use this model to do other things. For example, Q&A, chart summarization, image labeling, whatever. Okay. At the same time, we call it human in the loop, HITL. Okay, HITL, human in the loop. That means you use the human and the AI collaborate together, okay, to get the result that you want. Okay, so fine tuning can be expensive, sometimes can be not realistic. Okay, so if you want to fine tune your model, okay, sometimes it's expensive, and sometimes it's not realistic because you don't have all the data that you want. What are the more efficient way to actually do fine tuning? Okay, this is another way that you can actually fine tuning your model. So basically, fine tuning fine tuning is called parameter efficient tuning. Okay, so this method is to tune your model with your own custom data set without duplicating the model. So the base model basically is the same, but you only change some part of the model, fine tune. Okay, so this is what we call the parameter efficient fine tuning. Okay, you might not need to do this because now most of the foundation model are quite good already, but sometimes you have your own data that you want to customize it, then you can do this. Of course, there are other methods that you can do. For example, if you just want to do Q&A, you can do RAG, okay, which is the retrieval of augmented generation. I think this one will be discussed in next week talk. The speaker will explain to you. But basically, there are many other ways that you can actually customize your model with your own data. Okay, so here, this is one of the easiest way to actually fine tune is to do something we call prompt tuning. You actually prompt the tune the prompt to actually fit, okay, the model what you want to output. Okay, so let's say now you already have a generative AI. Okay, so how do you get the most of the generative AI? Let's say you want to start, okay, using generative AI in your company. Of course, there are three ways. One way is you can just use whatever available out there. You can just call API. Like if you are using ChatGPT, you subscribe to ChatGPT, you can build an application just by calling ChatGPT API, or you can use Gemini API. Another way is you can do some sort of a prompt engineering. Okay, you actually use a prompt and you set the prompt. For example, I want you say persona. I want you to be a medical professional that can answer only medical related topic. Okay, you set all these prompts inside your product. So when the person asks something, then the product, your app will only respond anything related to medical only. So that kind of prompt engineering you can actually set. And this one, you can make your model to be more precise and specific and can be useful response. Our last one, of course, you can do fine tuning. That means if your model, you have a very unique use case, you need to train your model with unique data set, then you need to actually fine tune your model or customize your model. Okay, of course, of all the three here, this is the most difficult one, and this is the one that costs the most money. So what are the risks of challenges of using all these large language models? First of all, the lack of transparency. For example, when you use all the model from Llama or from this model like Gemini or ChatGPT, you do not know where or what data has been trained. Okay, you do not know. Okay, you also do not know how accurate the data, because as I mentioned, the model can be biased, the model still can hallucinate. Okay, another thing is, like I said, you do not know what kind of data has been used to train the model. Sometimes some of the model has been trained with IP or copyrighted material. For example, you have seen the company recently, Disney and some movie studio, they are suing Midjourney because in Midjourney, you can generate images like Yoda or all these Marvel character. All these character you will generate is actually infringing the copyright and the IP. So then you ask, how come this model able to generate Marvel character or Star Wars character? Because this model has been trained with Marvel images or Marvel video, which is illegal because they are all copyrighted. All these models should not be allowed to train with all this copyrighted material. Okay. Another thing is, of course, now with all this model, it's also very important to protect all this security and fraud that can happen, and whether your model is sustainable. Because one of the problems with all this model is, as we move, you keep on have to improve the model because you need to model to understand what is the current situation or current news that happen. So sustainability is another problem. So in conclusion, the generative AI definitely is primed to make an increasing strong impact on enterprises. There are many ways that you can incorporate and also realize the benefit of generative AI. Of course, generative AI is still a very new field. There are many things that you need to be cautious about. So if you want to approach generative AI, you should be approaching it in a very cautious manner. So I think with this study jam, you are able to understand the concept, especially for this first week, the concept of the foundation model, the concept of the transformer, and then the concept of all this prompt and what this large language model can do. And then when you go and do your hands-on, you're able to understand, run some of the code in the Kaggle notebook. Then you have a better understanding the underlying fundamental of all this generative AI. So I think with that, I will conclude the session for today. I think I'll leave some more time for question and answer if you have any question answer. Of course, I will not able to answer all the questions. If you still have any question, you can ask, open a discussion question in the Discord, or you can ask a question in the Discord. Also, there will be other experts able to answer if I cannot answer today. Do you have any question?
Hi. So I think we can start with the Q&A session. If that's
Okay.
Yeah, I'll just I think we can start with the latest question. All right. So someone asked, what is parameters mean in pre-training?
Okay, so when you look at a neural network, there are a lot of let me show you the neural network. Okay, let me show you. So where's the neural network just now? Okay, so you can see if you can see that every single line here, okay, there is what we call weight. That means when the data feed, when the data go through from left to right, okay, the model able to, after many millions of data going from left to right, is able to calculate, okay, all the value for every line here. This is considered a parameter, the weight, all the parameter inside the neural network. So all these weight, okay, if you remember the basic concept of regression, y equal to mx plus c. Okay, remember y equal to mx plus c. So what's the purpose of the model is to calculate the value of m in it. So there's one weight, okay, the value of m. Imagine now you have so many x's now. Now you have, if you only y equal to mx plus c, okay, you only have one x. But here you have so many x. You have so many x. So every single value of the line here need to be calculated, need to be determined. Okay, and that all, once you finish train the model, that will be the value of all this value here. This considered the parameter. I hope that answered the question. If not, you go and read the paper. You can read the documentation that's provided in the week 1 resources. There will be explanation there also.
All right. Moving on for the second question, they ask, why is it that when I hand draw a research model, Claude and ChatGPT cannot reproduce diagram correctly?
It's very difficult to answer a question like that because the model are different. The model are trained in different data. The model, it might, first of all, maybe the prompt is also the way that you structure your prompt. Okay, most of the time, creating images is easier than creating a table, because table means you need to understand the context of the data, and then need to understand it, and then need to. I think the question is sometimes the prompt is given, but based on data, the large language model cannot understand the context that you want and cannot able to produce the image that you want. So there is a limitation now of most of the large language model were not able to create very complex chart or diagram. If you want to create images like picture of a cat or picture of a dog, that one is more easier because there is because you have seen many images of that. But creating a chart, you need to understand the content of data itself, and then need to it will not create the actual the precise diagram that you want. That's one thing. Second thing is another limitation of the most of the large language model, even when you want to create text inside your image, is also having problem, because first of all, creating images of a text is something quite difficult now for large language model. I'm sure you have seen people create Raya new greetings or Chinese New Year greeting, the text all jumbled up. Doesn't correct, because it's still one of the limitation now for the large language model.
Okay, so moving on. Someone asks, does hallucination happen because the prompt we provide is vague?
It could be. So there's a few ways like how you can reduce the hallucination. We can do something what you call future prompting, isn't it? Future prompting means you provide a few examples. If this is a question, this should be the answer. One example. If this is a question, this is the answer. Then you give a few examples to the large language model. Then the large language model understand, then able to produce. When you give another prompt, you're able to produce a more relevant answer. If the prompt is not correct, again, prompting is not one-time thing. Prompting is an iterative thing. If the first time the result not correct, then you need to iteratively go back and change your prompt until you get the result that you want. That's how you should work with the large language model. It's not one-time thing. Just like human, sometimes you tell a small kid, just imagine you tell a small kid, okay? A small kid, you tell it one time, the small kid say, oh, I might give you a wrong answer. Then you explain again, this is not what I want, this is what I want. Then the kid go back and think about it, and then he understand better what you want and gives you a result. So just treat the large language model is just small kid just learn. It doesn't understand everything yet. It will not give you the right answer at the first try. You will need to iteratively go back and change your prompt to get the answer that you want.
Okay, so someone asked, what programming language is used in decoding transformer model?
Okay, most of the programming for transformer model is actually at that time it was, I know at the beginning was not, I think it's Python, but I'm not sure. It could be Julia or Python, I'm not sure. But now most of the transformer model you can just call using the Python.
Okay. Okay, next question. Hello, sir. Does that mean when, for example, I'm asking any AI to generate an image of a dog and some part of the image seem distorted, does that mean the model isn't fully trained, or perhaps there might be an error in the source code itself?
I think generate a dog should be no problem, but sometimes you want to generate a dog sitting on a car or doing something very weird. Okay, so the model now generate images. He can just generate for you, but to you is wrong because this is not how the physical actual real world works. So to you is wrong, but to the model, it's not the model is the data is not incorrect, but sometimes you generate something that it doesn't work in the real world like that. So you generate something which is like very creative, like a dog wearing a spacesuit walking on the this a space station on a space. Okay, so you have not seen that in the real world, but he will try to generate based on the understanding what it is. But when you see it, it doesn't seem like logical because in our world, in our real world, we have physics that need to follow. So if you feel that the image generator is not correct, you just go back and prompt again and say maybe change this or this part is not correct. He will try to change it for you. By right, he should able to generate the image that you want. If it's a very general image like a dog or whatever, should be all fine.
All right. Someone is requesting, can you explain more on semantic understanding?
So semantic understanding is basically every like I explained just now, the tea and coffee. Okay, there are relationship between tea and coffee because both are them are drink. Okay, so that's how we understand. That's how we learn language. Just like when you learn a new language, you learn, for example, in certain language, there are certain words to express the same thing. Okay, so after a while, the model will learn that okay, every time people say I wear a hat, it's also same like I wear a cap. So a cap and a hat can be same. So this is what we call semantic. That means it has similarity and it could be synonym. So that is meant by semantic. That means you understand that the context of the sentence and in the similarity of the word itself. And what are the words that are similar and what are the words not similar. Then when you want to encode them, you put the words that are similar semantically to be the similar embedding space closer. And then they are not similar, then it should be a far be further in terms of the embedding space.
Okay, thank you. So for next, someone posted a picture of a diagram. I will resend it into the chat box if you're able to refer to that. They are asking what does the NX represent in this model?
Is it in the chat or what?
Yeah, it's in the chat in the MS Teams. Because it's a picture, they can't put it.
In the chat, I can't see the chat. How come? Oh. Oh, that is actually a neural network. NXM for neural network.
Okay, give me a second. My Q&A is loading. MS Team is a bit laggy now.
Yeah.
Okay. Okay, I think I can ask this question first. Is token used as measurement unit for transformer model?
Token is not a measurement unit. So token is like a. So when you send a prompt, to the large language model, okay. So you want the large language model, you break down your word into a what you call token, because you need to pass the word to the large language model, then the large language model will understand, they're able to predict the next word. So token basically is a one unit of a word. So if you read further the English word, okay, for example, I played football, past tense, okay, then I'm playing football, okay, I'm going to play football, okay. So the token for play actually is the same word, is play. So in terms of sending different word, so sometimes what we call is we actually put them into one token, and and then just send the word play over.
Right.
So yeah, it's actually a unit where you actually how you interact with the large language model.
All right, thank you. There's another question. Why there are cases where fine-tuning LLMs can cause the model lose their original capabilities?
That means you fine tune with again the data itself is very important, the quality. So if your data that you train is actually very lousy quality, it will override what you have learned previously from the pre-trained model. So it can actually make the model even behave, give you even bad result compared to the pre-trained model. So sometimes when you want to pre-train the model, make sure why you want to fine-tune the model. What's the reason? Okay, and then a lot of time people do not understand that the concept of garbage in, garbage out. So it takes a lot of effort to actually make sure the data is correct, first thing, and also make sure the data is not biased, it should be representative of something that, like I say, not biased. So a lot of work needs to be done to make sure the data is correct before you do fine tuning. People think that, oh, I just dump everything inside and then I can fine tune really. It doesn't work like that. Okay, a lot of work needs to be done also to make sure the data is correct before you can actually get a good result.
Right. Hi, doctor. Can I know why you prefer transformer rather than LSTM for generative model?
What's the question? LSTM? Oh, okay. LSTM is the this long-term short memory this model. LSTM, okay, one of the problem with LSTM model is where when the sentence is very long, the model will forget what it has learned at the beginning of the sentence. Because the model has you read let's say the sentence is very long. Okay, let's say the sentence got like 20 words. So when it comes to the 10 words, you start forgetting the word at the beginning. Then what will happen? When you come to the 20th word, some of the meaning at the beginning of the word will be lost. Why? Because there's no attention. The model does not understand which part of the sentence that you need to pay attention to, because you try to go through from the whole sentence itself. This is where the attention model able to solve the problem or the limitation of the LSTM, because from the context of the position of the word, the three things just now, the embedding, the position of the word, and the attention, you're able to understand the context of the word much better, and then he will actually pay more attention to the word, and then to understand the context of the structure of the sentence. This is where transformer is much better than LSTM. Because the LSTM, the limitation is has the sentence grow longer, more word, then some of the word at the beginning of the sentence, the information will be lost. So that's why the LSTM is not so good.
Okay, so the next question is, as a programmer, if I want to train the model to fit what I'm doing right now, what information should I give it? Is there a guide for this?
Yeah, go and read about all this fine-tuning model. Just now, like I said, the fine-tuning model. Go read about that. There's many technique out there that you need to do. There are distillation, there are like LoRa, all these other things that you can read about. Okay, it's out of the topic that for today. But if you're interested, just go and read about all this fine-tuning. There are a lot of methods out there that you can actually use to actually fine-tune your model.
Okay, there's quite a lot of questions coming in. But
yeah, so we cannot finish, like I said, we cannot finish all the questions today. What you can do is you can type the question and put into the Discord channel. I think it's also good that you type there, then there are more people can actually see your question, and then more people also can interact, and other experts that I invited in the Discord channel can also give their input also. Maybe you can do another 3 more questions before we sign off.
All right. I, maybe how does the self-attention actually works? Like in the embeddings and positional encoding, they convert into numerical vectors which translate into a vector space. How about self-attention?
Okay, self-attention later, if you read the paper, okay, there is a mathematical formula that they calculate that. Okay, so it's there is a way that they use a mathematical formula to actually calculate, then they put self-attention that to actually make the model understand where is the part of the word that is need to pay attention to in the sentence. So go and read about the paper, and also there's this podcast that's generated in the resource. It will explain that also. Okay, go and read about that inside this white paper.
Okay. When it comes to visualizing how vectors embeddings are stored, are they 2D or 3D?
Definitely not 2D, not 3D. It has multi-dimension. So the way that we show is we just can show until 3D only. So it has multi-dimension actually. It's very complicated to visualize more than 3D. So we just simplify it so you can see the representation like that.
Okay. Okay, so last question, is it?
Yep.
So I'm just going to choose one. Hi, Dr. Poo. Given that RAG is often cheaper, in what specific use cases would fine-tuning an LLM be most suitable approach as compared to using RAG?
Okay, RAG only when you want to deal with text data in there. So if you want to do a question answer, if your use case is just to do question answer, then RAG is very good. Okay, just like you want to build a chatbot, and the chatbot is just for you to ask questions based on the document, then RAG is very good. Okay, but imagine now I want to build an application where I want to identify defect or non-defect product for my factory. Okay, then that is very different use case already. Then you need to maybe provide a lot of different data related to your product that a RAG cannot do. Then maybe you think about maybe you need to fine tune the model. Okay, so I think but RAG also nowadays could be because now most of the large language model has a very large context window. Okay, like Google Gemini is 1 million context window, and some now are going higher and higher. So sometimes if your document is not a lot, you don't even need to build your own RAG. You can just upload the document, attach them, and then put in the Google Drive, whatever, and then you can just do RAG also. You can do that already. You don't need to build a RAG actually. RAG, you need to go through. Next week, the professor will talk about that. You need to actually do embedding again, need to store everything in the vector database, and it's a lot of process also that you need to do. But now, a lot of model are moving towards large context window, and then if your document is not a lot, you can just put all document in one and just do question. Then you can do all of this interactive question answer already.
All right, so I think that would conclude our Q&A session because there's a lot of questions, so we are not able to screen through and like all of them. But yeah, but someone asked, are they supposed to complete the materials before each session or only after the session? But
the material will be sent out to you every Monday. You should do all the do the thing before attending the talk, because you have that's why we schedule the talk on Saturday. The Monday yourself, like this Monday, you will be receiving week 2 already. You should go through it. Then when you come to the talk, so don't treat the talk like, oh, I'm attending lecture, then only I go do the assignment. Then it's impossible, because the speakers only have limited time. You cannot expect the speaker to cover a big topic and then you just want to listen to the speaker and then you don't do the assignment. You have to do the assignment, then use the speaker as a supplementary to help you to further understand the topic of the week. Okay?
All right. Yeah, I think that's good to know for everyone.
Yeah, so
the week one materials, it will be sent to you every week.
Yeah. The week one material already sent to email to you. If you're signing in using the Luma, the material already sent to you on the. If not, you can also go to Discord. You can actually get the material in Discord also.
All right, then I think we should conclude our Q&A. I think before we end, we can just take a picture of just everyone that we can fit. So those people that want to on their camera can on. Let me see.
I could not on my camera. Don't know why. Let me try again.
Maybe you can stop sharing the screen.
Okay, I on my camera now. Oh, they cannot on the camera, is it? Some they cannot on.
Or some cannot on camera.
Looks like they cannot on. It's disabled.
I see. Okay.
Never mind, just take photo.
Yeah. I think someone can just help take because my MS team is really laggy. So Stuart or Sophia, are you guys available to take the photo? Just try to get as many people in the frame and just take a screenshot. Oh, Dr. Pu's camera is working now.
Yeah, it's working.
Okay, Stuart, let me know once you're done.
Oh yeah, I'm done.
All right, Stuart,
Yep.
can you help share the ending slide?
Oh yeah, sure.
All right, so thanks so much, first of all, Dr. Poo, for the session. I believe a lot of people in the chat box are also pretty enjoyed it and also are saying like, thanks for the session and the sharing. Yep. And that would conclude our week one GenAI Study Jam. Yeah, so if you're not aware right now, the Luma that we have is actually through a ticketing session. So basically for week two, all the on-site tickets has already been sold out. So if you're joining for week two, you can always just go and register for the online session. But we just released our week three session. So it's on-site, it's available on our Luma right now, on-site and also online. So if you want to come physically to Sunway University, you can go ahead and faster book the on-site tickets right now before they're out. But if you prefer it online, there's also no worries. You can just register online. So yeah, that's all. If you guys have any question at all, can always reach out to us on our Discord. Or yeah, and remember to follow and keep up with Sunway Tech Club as well as Dr. Poo's user group, which is the AI and Machine Learning Malaysia. And yeah, thank you so much for being here.
Thank you. Thank you, everyone. Bye-bye.
If you have issues, you can always drop us a text. Okay, bye-bye. Thank you everyone for being here.